Hi, everyone, and welcome to another episode of So What About AI Agents. Today, we are talking with Rome Thorstenson, a software engineer and AI researcher who has been building AI agents across the cybersecurity stack. Rome was previously at Amazon and recently presented research at NeurIPS on mechanical ability, specifically on understanding what's happening inside mixture of expert models, which is the architecture behind basically every major frontier model today. He's now building agents that can analyze code bases for vulnerabilities, red team production systems, and do the security works that humans increasingly aren't doing because they're not reviewing the code AI writes for them. So, Rome, welcome to the show.
It's great to be here.
So, Dario Amodeo just said that AI writes most of the code at Anthropic. Sam Altman says the same things. And, people are building AI agents and not reviewing code at all. What does it mean for everyone?
Right. So, I guess the foundations where we got to start is that some absurdly high number, like some studies say 80%, some say even higher, of the code that actually gets shipped to production across the world, this is sort of like pre-AI and even probably current, is that it's not actually like completely secure. We keep finding a big class of vulnerabilities like memory vulnerabilities, which if you haven't done some crazy CS degree, it's not worth wondering about the nuances of this, but effectively like what's going on really close to the compiler is how you're keeping track of all the things you're doing and all the memory and data, and all sorts of things can go wrong with that. There's been a huge push in the last few years, especially with AI power, to transition from these sort of old legacy systems where it's full of problems in that regard to new systems. But that's just like riddled with vulnerabilities. We keep finding them decades that have been sitting in the code bases for decades. But then, all the stuff that humans write that, is the sort of stuff you'd think in your AI app gen apps or whatever that might look like. That too is, you know, 80, 90% of that is full of vulnerabilities. And the reason I'm bringing this up is because this is the data on which the AI is trained. Of course, we have ways to make sure that those code bases are secure, traditional methods, and then sort of this new frontier of AI-based methods. Obviously, though, the people writing the code to introduce these vulnerabilities nonetheless, they have access to the same tools that you might say, well, let's just, scan the code bases that the AI are trained on and make sure there aren't any vulnerabilities. Like, we're sort of doing our best, and yet even so, what makes it to the training data is problematic. And so we don't really have reason to believe that these models are going to be fantastic at vulnerabilities. But then, okay, actually getting to practice and saying, hey, Opus 4.6 or whatever it might be, Codex, go and, code me up this app, or let's, go on Lovable or Bolt or Replit or these other systems that sort of package it all together, go build this for me. They have their own built-in security checks or, good prompting or whatever it might be, or, code review is a huge thing right now. A bunch of startups, bunch of, Claude Code ships with a code review agent, even a security agent. But ultimately, like when you actually peek under the hood and see what those are doing, what's really going on is it's just saying, hey, Claude Code, double check what you wrote and make sure it's not full of vulnerabilities. And that's actually surprisingly good. What Opus 4.6 can do, Anthropic just put out right when they released it, so they have a team dedicated to this. Maybe a whole department, I'm not sure. But they sort of tasked it with going out and finding vulnerabilities, in particular these memory vulnerabilities I was talking about. And it actually did surprisingly well out of the box. Like, that's something that I've been really impressed by and really interested in following, is that these models can do really well, like surprisingly well. And that's fantastic, but it's not everything. And when people don't even bother to do that step of say, hey, go check the code base, or, here's some useful context, go do a review or go do a very thorough review. Maybe you're trying to conserve token costs. I'm sure many platforms, they just spent, God knows how many tokens building the app, and they're trying to be, cost effective and, show investors growth and whatnot. So the incentives really aren't necessarily aligned with these big platforms to spend a lot of tokens making things secure. Now, obviously, they don't want their apps to get hacked, and you don't either. But there's some frontier where there's, optimality trade-off between cost and effectiveness. And if you're not really thinking about that and you're not actually using, like most 90-some%, I don't think there are good numbers on this right now, but some huge percentage of developers, especially like non-senior developers who haven't been around and really experienced this, whether in, working with some company where there's a big data breach or whatever it might be, really don't have a full grasp of the severity of these things, even if you see on X or whatever. Like there was a big scandal last summer where a bunch of driver's licenses got published.
Right.
And hacked. And, you see these things, and based on my experience and the developers I've talked to, it's a huge priority to think about security, and security is important, but it always gets pushed down the to-do list for the next feature or the next release, the next customer, or whatever it might be. And so I'm really thinking about how to make security as simple and native to these platforms as possible, because yeah, it's so easy to miss, and it's really hard to figure out this balance between what's worth it and what's enough. But yeah, I think it should be higher up on the priority list than most people give it credit for.
So you mentioned that you're building agents across the whole cybersecurity stack. Can you walk us through what these agents do?
Right. Yes, absolutely. So the first and sort of biggest priority for me is you have your code base. Maybe it was written by AI, maybe it was written by humans, maybe it started with a template written by humans, and then you had your AI go in on top of that. And you build this out, and then you're ready to deploy this new feature or make this release or whatever it might be. And you have some confidence that that code base is mostly secure. One tangent I think we'll come back to is that knowing that a code base is secure is a really hard problem, not only from like here, let's check this and just find the ground truth, but even from a benchmarking or an evaluation standpoint. Because, like I said, some of these vulnerabilities have been hidden in code bases for decades. And so it's very hard to get to a point where it's like, okay, we know this is secure, especially because of sort of what's going on under the hood. It's not just like the TypeScript code that you write or the Python code you write is secure. What's going on under the Python or in the Python itself, you have no guarantees that that's actually going to behave the way you think it is, especially on, once you take it from your sandbox little local host to actual production environments. That's a whole nother can of worms. All right. Back to the main point though. What do these agents look like? So first things first, you get a code base. And this is the primary service that Rafter offers, and really where I'm focused right now is you get a code base, and then it's our job to look through that and find the vulnerabilities. And the way you can do that is you can either say, let's use a bunch of traditional school tools. They use things like pattern matching and reject space methods, which is just pretty much more pattern matching, all sorts of like really understanding how you go from like the code that you see as a human to a compiler that breaks it down into its different structures and thinks about like functions and all these things. There's a very nice, well-structured thing that might be easier to reason over, down to like the actual, bytecode that makes it to the actual CPU. And then you got these traditional methods, and they're good in a lot of ways. One of their big flaws, aside from, the scope and what they're actually capable of, is false positives. And this is a big thing that sort of plagued the cybersecurity industry for a long time, which is, okay, I have these tools, they flag, hundreds or thousands of issues. Do I really want to then spend, hundreds of developer hours going through and checking all of these? Okay, so that's the traditional picture. Now, how do agents come in and actually sort of upturn that? Well, first of all, you can just say, Claude Code, go review my code base and see what it is, or Codex, go take a look. Now, often these agents just sort of ad hoc go through and decide what's necessary and important and look at some subset of the code base. Another way you can go through it is you can index all the code base, like the whole code base, sort of RAG style. You can sort of think of it like that, and then say we're going to analyze this particular file or this particular function, and then retrieve the relevant stuff as the index supports, and then go from there. Or you can build it in, you sort of sky's the limit. Now, what I've focused on and what I think is really the best way to approach this is to sort of do a mixed bag of, well, the static scanners are good if we can make sure that we understand the scope of what they're capable of, and we can deal with all the false positives.
Mhm.
Indexing is good if we can make sure the context is relevant. In my experience, that has actually been a rather difficult problem, but sort of one of the biggest and the most important thing with developing both the agents and the models, just in general, is actually building good evaluations and benchmarks. You sort of hear these words thrown around sort of interchangeably. The way to think about evals is more, we want to evaluate this against, as a company, against our own internal tooling or whatever it might be, like versus benchmarks. It's like, okay, this is out in the wild. We want other people to use these to compare state-of-the-art models or state-of-the-art, agents or tooling frameworks, whatever it might be. At least that's how I think about it. And so what's really lacking in the cybersecurity industry and building these agents is actually understanding and building these good benchmarks, not just for here's a bunch of file or here's a particular file. Can you find the vulnerability or vulnerabilities? It's here's a real repository that is used in production or is open source, of which there are so many. Can you find the vulnerabilities? And some of this exists to some extent because what you can do is you can look at these open source projects and then grab all of the instances where someone committed something or like made a change that was like, hey, I found this vulnerability, here's the fix. And that's great, except for the fact that you're sort of doing it one at a time. You've got a giant code base and you want to pick out that one thing that's in there and see if you can find it. And that doesn't work for a few reasons. Firstly, the problem is you're looking for sort of a needle in a haystack, except there might be many needles you know about, needles you don't know about, like yet to be found vulnerabilities. And you're saying, can you find this one or not? And that's bad because it doesn't deal with the false positives problem, which is still relevant for AI agents, but it also is, do you really want to then spend the token cost or whatever it is to, analyze these giant repositories? And so there aren't very good benchmarks for the problem of give me a code base, let me find all the vulnerabilities and then give you sort of the result or tell you exactly how to fix them or fix them directly. But what the agents that I've sort of described, sort of a host of different agents. And I think, the best approach is sort of a mixed bag, but sort of a good foundation, honestly, is um, Cloud Code or Codex with good tooling. That sort of seems to be the best foundation right now. And then to really get the most of it, you start stacking in these other components and these other tools. But yeah, we need better benchmarks and evaluations.
Interesting. So, but isn't there like a leaderboard problem here where basically we are stacking up against benchmarks? So let's say like what is the target for the agent? Does it need to find like 80% of the vulnerabilities? Like what is this? What does success look like? Because like back in the day we used to have SonarQube, we ran SonarQube, it gave us a list of things that went wrong, we fixed them manually, we were fine. Nowadays, from my understanding, we can do a lot more with the agents, but what concrete things can we do? Like I have a code base. I would like to, in theory, scan it, every month for all the vulnerabilities that I introduce every few weeks. And, I can say to Claude, okay, let's review all of our past PRs, go ahead and, pull the and figure out if we made anything vulnerable. Sometimes it will give me good results. Sometimes it will not. Uh, how do I trust it to do it properly?
Absolutely. So here you sort of nailed or like hit on one really important problem, which I found doing my own evaluations and benchmarks, which is they're not consistent. You might build this particular framework, this particular code base, and then run it a dozen times and get a dozen different lists of vulnerabilities. I mean, there'll be some overlap, of course, but because of how these are structured and how these sort of like naively approach things, there's really no reason to expect that they would find all the same vulnerabilities, even if you set like temperature really low or these other things you can do to try and make the models more deterministic. I mean, sort of inherently, they are non-deterministic just because of how they're built and implemented. And so, yeah, you'd want to be able to do that. And I mean, Rafter does offer that service right now, but ultimately, sort of where we're going and sort of the future of AI cybersecurity agents and what Rafter is currently building is fully autonomous. This feedback loop where because the agent is not only responsible for finding the vulnerabilities, it then has to go and fix them. It has to challenge them and decide, well, do you really want to bother fixing this because this is a real problem? And then actually figuring out the design decisions to fix that problem, which seems like on our works thus far, seems like a really powerful way to sort of challenge and validate these findings. But to get back to your question, yeah, I mean, you've raised a really good point. The way this changes is the traditional tools improve. Hopefully there's less false positives. And then it's much more powerful, especially challenging and sort of validating these findings because, traditionally tools can't say, okay, I flagged this based on my best knowledge. Now let me go back and actually, check my work. The whole point is the tooling that found it. And that's the best effort. But nowadays you can have with semantic context and like, you can have the agent sort of debate back and forth, is this a problem? Is this not? And that really improves the quality of the signal. In terms of the benchmarks, like, 80% or whatever, the big problem, going back is you don't know if the false positives based on whatever benchmark you have or found is actually a false positive because it might just be a vulnerability you haven't found yet. And so coming up with these really meaningful metrics is a very challenging problem sort of in this space because, you can't rule out mistakes for undiscovered solutions.
Right. The only context that I can think I can provide to vulnerability agent is like how do we secure things inside of my app, right? So what kind of permission systems we have, what kinds of other things. But when we talk about vulnerabilities are usually something that's easily missed. Sometimes people can, query your API and get your AWS key back, like in the worst case
Yeah,
scenario.
that's pretty bad. But yeah, absolutely.
So how do we like you talked about these autonomous loops. Walk me through the architecture of the autonomous loop for the agent. So the agent is scanning your code base on daily basis, right? It's running in the background. Can you trust it to make security fixes autonomously on your code base? And can you trust it to verify those security fixes? And if so, how?
Absolutely. So the first sort of problem with a fully autonomous feedback loop is that Oftentimes, the reasons the vulnerabilities get in there in the first place, and for example, the reason, as I brought up earlier, that a lot of these legacy code bases are full of vulnerabilities is because of deadlines or certain features or whatever it is that sort of pushes you to make these changes means that you're compromising between security and results. That means that making these changes in the fully autonomous feedback loop requires design decisions. It's not just you were trying to do this, you did it the wrong way, and we can do it the right way. It's this particular approach or way you're supporting this API tooling or whatever it might be is sort of fundamentally flawed, and somehow the design needs to change. And that's sort of the biggest problem as I see it right now, aside from the trust component, which is sort of a quality of model problem, is that you need to then make the design decisions to say, well, I want to do it like this instead or like that. And oftentimes the models are pretty good at making that recommendation, or at least giving you the context you need to make that decision. But in terms of the pipeline, I mean, in just the code base, the model does some sort of analysis. It generates some list of findings. Usually there's some sort of skeptic or challenge that says, are these serious? Are these real? You can sort of cut about a lot of this. You can almost do it all in one if you wanted, which we find not that successful. And then, say, submit the PR, whatever it might be, with these like design decision questions. And then the matter of how much you trust it is ultimately, yeah, like 6 months ago, I would have said this is a huge problem and you still need to review it yourself. With current sort of the art models, there is some threshold now where, like, I personally, just in my own development experience, feel comfortable saying, yeah, this sounds totally reasonable. It sounds like you have a good plan to fix it. Go for it. Now, I haven't gotten to the fully autonomous loop myself for production environments, certainly for side projects or whatnot. Yeah, that's sort of where I'm at now, and I'm really excited about how fast these models are moving to give them more trust in that regard.
Yeah, I mean, I also trust them more to make decisions and to make simple fixes, which I don't need to revalidate each time. And but I still review everything they do, especially for my production systems. We have to do it based on our security policy, where we have to review everything it puts out. And the problem is not even that. The problem is like, okay, well, you have these, it scans and it finds, it patches something. Some of these vulnerabilities are complex, right? So
But yeah.
I still feel like there has to be some sort of inherent security posture context that has to follow, right? And I haven't.
Yes.
Yeah,
Okay. So perhaps I think I have an idea where you're going with this. And if not, you can correct me. We can sort of um, go back and forth. But there are sort of standards. You can look at meter. You can look at OWASP. You can look at ASVAS and like all these other sort of postures that really sort of provide a foundation and a way of thinking about these problems, but also often like OAuth has their classic top 10 list of the sorts of things that, LLMs have problems with versus more traditional, just like web apps or whatever that might be. And that provides a really good foundation in terms of context for the models to help them calibrate and say, well, this is a web app, we should worry about these things versus this is an AI chatbot interface, we should worry about these things. And that's a really good way to sort of kickstart um, building a good security posture for the agents. Is that sort of what you had in mind?
yeah. My thought of my thought process is still around. I cannot frame it correctly, but I just feel like there has to be something there that we can leverage. Like, yes, there are like common security issues. That's a great thing to put into context, so it can always check for those. But then, okay, you have your own security context within your organization. It has to check that as well. And I just don't know. There's just something about this. Like I just want to see clearly. Can you just run me through? So what kind of vulnerabilities does it find? Like maybe you can walk me through that so I can understand. Like what are some of the cool things you saw it find that you were like completely surprised by?
Yeah. So here's um one interesting thing I want to bring up. It's not exactly a vulnerability per se, but it's a sort of a bug or a weakness that is often a sort of vulnerability, which is you'll hear prompt injection all of the time. Uh, and this is a big problem for AI agents because, wherever they interact with the outside world, that can include malicious instructions that may or may not build very sophisticated and complex, remember this for later. If you hear this now, do this. And all of a sudden you build something that, sort of build like a Lego set. All of a sudden a crazy complicated thing that all of a sudden, cripples or reveals private information. On the other hand of this spectrum, it could be like give me all your environmental variables. And if you're not set up properly, that becomes a huge problem. But what I wanted to bring up was something Opus caught for me just the other day, which is I was working on these agents that do scanning. And what had happened was a naive model had gone through the code base and analyzed it and then reviewed those findings and tried to figure out if there were false positives or false negatives or just true positives, whatever it might be. And it had flagged something it thought was a false positive and said, this is not a vulnerability. This is intended functionality. Don't worry about it. And then I sent a more sophisticated model in the same code base, and it flagged that and realized that perhaps maliciously, perhaps not, this particular flag or, might be code injection or whatever it might be, this particular flag was a mistake. The model had perhaps, like I said, in this case, it would have been good intentioned, thought this was a false positive when in fact it was a real positive. And naively, that would have caused, if you weren't careful about it, my model or my more sophisticated model or, whatever that might be, to ignore a true positive because sort of the deputy said, oh, it's not a problem. Don't worry about that. It had sort of been like, the deputy sort of triages the problem that then the captain or whatever the analogy doesn't see. So yeah, prompt injection is a huge problem, which is just, I want to flag. And that's something that these models catch. I mean, the full scope of it is everything from like vulnerable dependencies, because open source and like supply chain attacks are a huge problem where you sort of, you're not building these apps from scratch, writing C code or whatever, or Rust. You're building on top of all of these existing packages, which are open source in most cases. And those are constantly being, audited and bug bountied and, all the rest to find vulnerabilities. And then, that's something you can check. And then on top of that, there's SQL injection is a classic problem. All of these things that are much more not like memory issues, which is sort of outside the scope of day to day, and usually what I think our audience and AI app builders and those sorts of problems. It's not really that stuff, but it's much more business logic. It's much more, can I get past this paywall all the way to these supply chain injections or secret detection is a huge thing, especially not so much these days, but like a few months ago when these app builders were coming out, especially like last summer, huge problem. And then, does that give you a good sense for the sorts of things that go wrong? I don't want to get too much in the weeds because otherwise we'll be here all.
Right. No. This makes a lot of sense, especially when it scans it, and then like a previous coding agent said, yeah, there might be an issue here, but don't worry about it. And then it reads it, so, okay, I shouldn't worry about it. And then it's like they convince each other.
Exactly. And then this becomes so then you have to tune, okay, well, how do we solve that problem? Do we strip out the comments? Well, that's a terrible idea because the comments provide a lot of useful context. Okay, so we do add something to the prompt that says, ignore the comments that say this isn't an issue. Can we trust the model to rely on that? I mean, maybe 6 months ago, no. These days, probably. But yeah, that's or you can start saying, well, maybe we go back to pattern matching and say, remove all the comments that have the word vulnerability or security or anything like that. And you say, great, wait a minute, those probably included some useful context. I mean, there's a lot of nuances to how to really set up these agents to be able to succeed.
So how can people get started with Rafter, right?
Absolutely.
Just so I understand, like, is there an MCP I can connect to, or how does one get it into their code base to start to use it?
Right. MCP is, well, to avoid another digression. So Rafter ships CLI, which you can totally use. And in fact, by the time this podcast is out, we're going to ship some huge upgrades to that, which include agent sort of native features such that you can install the CLI and then things like for OpenClaw, for Claude Code, you can actually import skills and other tools to really directly empower the agents. This isn't just like a, regular CLI or, that you just call. But without getting into too much detail there, the simplest way to get started with Rafter is to go to Rafter.so, sign up in 1 click or 2 clicks to prove GitHub, and then you can scan a code base instantly in 1 click. And the whole point of that paradigm is to make it as simple as possible to get people really taking security seriously. Too many solutions right now, and just traditionally always, are complicated. Complicated, take time to set up, require developer experience. People who are developing now, like I can't remember the last time I wrote more than a line of code in some code base. Like I'm using these tools, and though I have the development experience and really understand, and I'm very happy to review the code and make these decisions and think through them. A lot of people don't need that knowledge and are happy to trust the models. And so I want to make this accessible to as many people as possible. And so yeah, you can run a scan for free I should mention, right now in just a few clicks and get results in minutes, and then get prompts to copy and paste directly into your code editor, whether that's Codex or Claude Code or Lovable or Bolt or Replit. Absolutely no technical knowledge, literally clicking just a few buttons. And that's more just to start than to make any design decisions and to tell me which repo to scan. Like that's all there is to it. Um, and the whole point is, yeah, the power of the simplicity. Now, if you want to go deep, the sky's the limit. CLI tool, um, which is, here, I think NPM is, well, let me confirm I have this right. Yeah, Rafter security /CLI, but I would recommend just going to Rafter.so, and then you can click over to the docs and see the exact command. But you can just pass that off to Claude Code or Codex or whatever, and then it'll take care of it.
That's what I would do. No, it makes sense. I also don't use MCP. I just use CLI, and I build custom CLIs, and I don't use skills either, to be honest. I don't see a point in them. I just let go, use the CLI, and it runs all the stuff that I need. And I don't need to, I don't understand skills, to be honest, but that's just me.
I mean, I totally get that. I mean, ultimately, it's a markdown file with some good context. Sort of, I think the way to think about it is to sort of modularize the context window, and sort of say, you can go through this skill to get to a bunch of useful context that you don't always need access to. And it's a nice way to package it. Like that's really what the skills are doing. That's a lot better than MCP, which has its own problems. I mean, everything from prompt injection to, sort of sky's the limit there. Like MCP is not a perfect solution, especially from a security standpoint. Um, but yeah, I think CLIs, especially models, are so good with CLIs. It's simple as that. I mean, you run the help to get more context, and that tells you exactly what you need to do, and then you go from there. And I think really CLIs are going to be the future of the
Yeah,
paradigm, and so that's what we're really focused on.
that's what I use as well. I have AWS CLI, every kind of CLI for everything, and it just runs those commands, and it's able to operate all those systems for me. I don't even remember last time I used the AWS GUI. Everything is done via the CLI. And that's
Yeah, yeah,
you don't need to. So let's now shift into something else. Like you recently presented your research at IPS on mechanic and interpretability. I'll be honest, though, for our audience, it's a deep ML research, right? But I think it matters for anybody who is building with AI. So help us understand, what is mechanistic interpretability, and why should people care about it? Like us developers who just build and ship agents.
absolutely. So, for a little bit of context, NeurIPS, as some people say colloquially, are the neural information processing systems. 2025 in December in San Diego. It was the biggest AI research conference ever held, I think. Um, and what they sort of have been shifted into the spotlight because they're very early on the next token prediction and sort of the fundamentals of the current state-of-the-art AI models. But what mechanistic interpretability tries to do, and what interpretability in general tries to do, is look at models and understand exactly how and why they go from their input to their output, or sort of like peer inside the black box that is these weights and these activations and these functions to really understand what's going on and why it gets there. This is really important for a lot of reasons. First of all is alignment. Like we want to make sure that the models are like not lying to us and behaving in the way we want. And mechanistic interpretability specifically focuses on sort of the mechanisms, to give a word, but sort of causality. Like we want to be able to causally change these models by intervening. If you remember way back when, there was a lot of hype around Golden Gate Claude. Effectively, this was an interpretability project where Anthropic researchers went in and effectively dialed up the Claude dial. They found the dial, first of all, which is no small feat, and then dialed it up to the max so that every response had to do with the Golden Gate. And that was sort of, at least the beginning for me. That's when I first heard about this. But what I was working on specifically was how features are represented. And there's a lot of different ways to think about what's going on inside the model. One pretty strong hypothesis we have is that models sort of work in terms of features, where one feature might be the Golden Gate feature or might be the cat feature. Now, this sort of breaks down if you're talking about a bunch of different cats in the same prompt, or golden gates, maybe. But it's sort of a useful paradigm to think about, and we have ways to sort of decompose the features that a model might be thinking about, maybe. And then when you start to get more complicated, you sort of build up circuits through the model, which you can sort of think of as like electrical wiring circuits, except these circuits are sort of distributed across a bunch of neurons, across a bunch of layers, and really disentangling them is still a huge problem. But the idea is if we can sort of build these circuits and understand these features or these concepts, which might be further abstractions on features, we can really understand what these models are doing, whether they're faithful, whatever else might be going on. And this has led to a lot of really interesting insights. For example, some anthropic models are aware when they're in when they're being evaluated versus when they're in production. What this means is that they can behave in different ways, which means when we evaluate them on our benchmarks, those might not be representative of the model's true capabilities. And you can imagine how quickly that can go wrong. So it's a really interesting and important field, and I think it'll only become more important in the next few years. What I was specifically interested in is traditional models, like way back when, like early GPT models, were dense models. What that means is that sort of everything stacks on top of each other. You get some input, it goes through one block and the next block and the next block, and sort of just streams through. Mixture of expert models, as the name might suggest, employ different experts, and the way that works is you take in some input, and then it goes through some sort of router, or sort of like maybe, the front desk at the doctor's office or whatever might be. And then it sort of assigns you to a doctor, a team of doctors that are sort of the specialist for your um, particular problem or your particular challenge or prompt, or however you want to stretch this analogy. And then instead of talking to all of the doctors all at once, you talk to, the top four or whatever it might be. And this has proven to be extremely effective. Most, if not all, of the current sort of best open source models are mixed expert models, everything from GPT OSS to the new like Kimi K2, 2.5, all these models. One interesting thing to note actually is that you might hear parameter count just going to the moon. Kimi, for example, trillion parameters plus, but you might say, but it's still really efficient. And that's because it's using these mixed expert models, because it might have
Mm,
a trillion parameters, but it's only going to actually be using, I think for some of the Kimi models, is somewhere around like 32 billion at any one time. And that's because it might have, a dozen doctors in the office, but any particular input only talks to 4 doctors. And so what I was really interested in is how do features change when you go from dense models to mixture expert models? Because unfortunately, sort of the core of these models is not just like we have, a giant checklist of, are the cats present? Is there a Golden Gate Bridge involved? You just go down the list. It's not really like that, because the models don't have space for that. What they do instead is they work in this really high dimensional space. Oh goodness, this might get very technical very quickly. Effectively, models can think about a lot of things at once without sort of having a yes no checklist. And that becomes complicated when you split across different experts.
mm,
And we were sort of looking at how that changes from the dense model, where sort of everything is present all the time, to, well, maybe expert one deals with this cat's feature more than expert two, which is really, the dog lover sort of thing. And that's very simplified, and cats and dogs, and I mean those are totally valid features, but yeah. So thinking through that, is sort of a more foundational approach to interpretability, which especially during NeurIPS, for example, there was an interesting debate about sort of whether you should focus on a more foundational or theoretical approach to really build the foundations, or on the other side, focus on a more pragmatic approach that could really, in the very short term, help you build better models. And they both have their values, but I think certain people advocated very strongly for a more pragmatic approach, and it was very interesting to hear some speeches and back and forth on that dialogue, sort of live at the conference. Certainly, I think
mm.
a very interesting field to be a part of right now.
So you're saying that models with more experts are naturally more interpretable. Each expert handles fewer concepts cleanly, and it's more secure in that way as well. Or is it not more secure?
Well, security, it's probably too soon to say, but you've really hit on actually one of our sort of main theses and sort of claims we were trying to advance in our work was exactly that. The bigger models are in fact more interpretable. And we found some pretty compelling evidence for that at really small scales, really toy models. Um, and the reason we're working in toy models is because it's much easier to disentangle the features. Future work that we're really interested in pursuing is sort of scaling that up to bigger models. But yeah, in terms of security, one thing that interpretability could allow you to do, especially if you can tie the features down really well, is like maybe certain sorts of prompt injection cue you into certain features. It's like, and then you can use that to sort of flag prompts by running the model, as opposed to doing, other models that look at it and say, hey, is this prompt injection, or should I be worried about, this particular problem? Now, people are doing that directly. You don't necessarily have to go through features to do that. But that's sort of another very interesting direction in sort of the interpretability field. But yeah, especially as these models get more sophisticated and more independent. You mentioned sort of at Anthropic, some, nearly 100% of the code written there is written with Claude Code and with Claude. I mean, you see the similar things from like OpenAI, where I think the claim was like GPT 5.3 codex was critical to its own development or something to that effect. Um, that those claims, when the models sort of get this self-recursive feedback loop, like we're going to want some way to peer inside and make sure that they're doing what we want them to do when they're the ones figuring out their own sort of next directions. And so this field and sort of these questions are extremely relevant and only going to get more so.
So, how does this research connect to the security agent work that you're currently doing? Can you actually understand what's happening in these models? And does that help you build better security agents right now?
So yeah, unfortunately, there isn't a direct link yet. The work I was doing there was sort of hoping to build the foundations so that we could get to a point where there would be a meaningful link. But unfortunately, the field really isn't far enough along yet for me to see real value in sort of the agents I'm building to make them more secure. Now, that said, this research can help, maybe not directly, but indirectly, again, building the foundations, make the models better and better at security, which again is only good for defensive cybersecurity progress.
And now, for the people who are shipping agents to production right now, what are the top three things they should be securing in their code? And what are they probably not doing? And what should they be doing?
Right. First things first is prompt injection. If you are shipping agents that interface with external content, content that you aren't moderating or sort of overseeing, then prompt injection is a concern. Even if you are overseeing it, it's very easy to get hidden in a white text in a PDF document or whatever that might be. So it's easy to slip by, and having guardrails in place for prompt injection is extremely important. Second, I would sort of focus on, right now we've mostly focused on white box code analysis. So, Opus writes the code, then still has access to the code and does that analysis. But that's not the full picture. And so I would sort of align items 2 and 3 to be white box analysis. Don't just tell Claude, hey, do it better. Use a tool like Rafter or something that sort of goes further than just the, hey, check your work, to something that's much more principled and using the tools and the context that will really empower the agents to do that job the best they can, while still remaining sort of cost effective. So yeah, don't skimp on the white box security, but then also something to think about is not only, okay, you've analyzed the code, you've dealt with prompt injection to some extent, but then you've actually deployed it to production. And often that comes with new problems. There's a whole field we sort of talked about. I've been working around the term SAST, or static application security testing. There's a whole nother realm called dynamic application security testing, or DAST. And you can sort of go even further than that and talk about red teaming. And this is something I've been following very closely, especially in the last few months, where recent academic work has shipped some really interesting models. For example, they developed an agentic system, which sort of had an orchestrator and a bunch of sub-agents. They went and they deployed it. They were Stanford researchers, but they deployed it against the Stanford computer science infrastructure. And what they did is they said, we're going to have 10 cybersecurity professionals try and red team. Red teaming is sort of breaking in and seeing, we're not the bad guys, but we'll pretend to be the bad guys and see if we can get in, and then we'll tell you how to fix those problems. They had 10 humans try and do it, and they had 2 agents to try and do it. And the agents did really well, pretty much, which means cybersecurity is going to get only ever more important in this next year. I mean, malicious actors now have the tools to build agents that can move so much faster than traditional security paradigms. What used to be the case was that you would have days, months, years, if you were a really small operation, to patch these vulnerabilities, because sort of the bad guys would never get around to you. They had bigger priorities. Nowadays, they can have agents constantly watching the reports that come out. It's like, oh, here's a new open source vulnerability. Everybody go and update. They immediately see that. They deploy thousands or huge numbers of agents to check all sorts of websites across the web to try and exploit these before the defenders can get in and actually do remediation. And so I would prioritize not only white box analysis, but sort of continuous monitoring and thinking about how you can develop solutions that mean that, you're not just, you don't check your work once, but you constantly are updating your security posture and always checking, because the fact of the matter is the code isn't, you can't just do a one pass and say, oh, it's not vulnerable. Because again, you're not only checking your code, but you're checking all the code that your code depends on. And so, these are the things that I, with Rafter, am thinking a lot about, thinking about building great solutions for. But it's also something that the developers really need to prioritize, because what used to be not a problem because the bad guys wouldn't get around to these projects. And I say that, but I've had sites that have been hacked from way back when, old WordPress plugins, or God knows what, way before the era of AI, before I was really sort of deep in the cybersecurity era, or the work. And like, it was bad before, but in terms of the power that malicious actors have, it's only going to get worse. And so I would really prioritize being proactive about your security.
Yeah, I mean, it used to be a skill issue to these smart people systems. So they would prioritize high value targets that are, or medium value targets,
Exactly.
but that are easy to hack. But now you have a slew of people who were not smart enough to hack, powered by agents who can now do this stuff, and they will target you because, well, they're not that smart to begin with, right?
Well, that they don't even need to like, it doesn't really matter about smartness. Like, you raise a really interesting
Right.
point. I was thinking, like, the experts can then deploy agents, but of course, now everyone is an expert, not only in writing code, but in breaking code. Um,
Yeah.
and so this is only gonna become, yeah, more relevant for everyone, which is a good thing for security because it means everyone it's gonna push up the bar, but the transition phase to sort of get to that point, it might be ugly. And so it's gonna be really interesting to sort of in the next year, I think. Yeah. Interpretability and cybersecurity are both gonna be, very, critical fields.
So everybody, this is Rome Thorstenson. Thank you so much for joining. Check out Rafter.so for your automatic security vulnerability scanning. Thank you so much for being on the show, and I hope to see you again here.
Awesome. Thank you so much for having me.
Thank you, Rome.